why can't I do this? Okay, let's have a look. We have the limit as x approaching infinity of square root of x squared plus 4 and then minus x. So what you did is, well, I think you noticed that the inside is almost a perfect square, so you added the 4 so you can complete the square. If you do that, the inside turns out to be x plus 2 squared, and then with the outside square root, they cancel, so you end up with this. And then minus x, and because you added the 4 here, so you subtract square root of 4 here, and you end up with 2. However, this step is actually not correct. Why? Let me give you an example real quick. Suppose I start with square root of 5. Have a look. If I decided to add 4 inside of the radical right here, right? And then on the outside, I subtract square root of 4. Is this the same result of this? Well, actually, no. Have a look. Because you have to do this inside out. 5 plus 4 is 9. Take the square root of that. So here you get 3. And then this right here is square root of 4, which is 2. So you end up with 1. So you started with square root of 5. You can end up with 1. This right here is now okay. So this is now okay. Well, what you could do, this right here is the correct algebra work. If you have square root of that, x squared plus 4x, if you want to complete the square, yes, you can add the 4 here, but you will have to subtract the 4 in the same square root. So you can end up with these 3 terms become a perfect squared. And then this right here, okay, it's minus 2 squared. And then they are inside of the square root. However, because there's a minus here, again by the order of operations, you will have to work this inside out. Do not cancel out the square and the square root. No. So even though this is okay, but for this question, it's not helpful. But not helpful. In fact, later on, once you get to Calc 2, when you do some integration questions with radicals, it's actually okay and helpful to complete the square inside of the radical like this, but not here. Alright, so how are we supposed to do to solve this right here? So firstly, if you put infinity into all the x's, I will tell you this is in the infinity minus infinity indeterminate form. You cannot just say the answer is equal to 0 right away. We actually have to do more work in order to be sure of what the answer is. And in fact, I don't think the answer is equal to 0 for this one. So what do we actually do with this though? Here, when we have square roots, go ahead, multiply the top and bottom by its conjugate and just give that a try. So right here, I'm going to start with still the same limit. And then we have this, right? And then I will multiply that by its conjugate. So it's square root of x squared plus 4x, but plus x. And then we do the same thing on the bottom. So we will just divide this right here. So square root of x squared plus 4x, and then plus x. The beauty of multiplying out the conjugate is because of the difference of 2 squares. Here, note that if we have a minus b minus b, and then if you multiply that by a plus b, the result for this is just going to be a squared minus b squared. It's the difference of 2 squares. So right here, we can just get the following. We will just square the first term. So I will just put down square root of x squared plus 4x, and then we square that, and then minus the square of the second, which is x. And then the bottom stays the same. Alright, now you see this and that cancel out. So the top is just x squared plus 4x, and then minus x squared. So in fact, this and that, they cancel. So we have the limit as x approaching infinity of just the 4x right here, and then the bottom stays the same. Now, if you put infinity to the top and bottom, you will notice this is an infinity over infinity situation. You're going to select the dominating part, which is just the highest power of x, on the top and also on the bottom. Remember, x squared instead of the square root, it's x to the first, because x is passing infinity, yeah? And then this right here is also x to the first. So this gives us the limit as x approaching infinity. The top is 4x, but the bottom, this right here is x. Remember, x is passing infinity, so it turns out to be just x. The question will be trickier if it's negative infinity, so be careful with that. But anyway though, x plus x, we get 2x on the bottom. Same degree, right? So they cancel. 4 over 2, the answer is equal to 2. So that's how you do it. I do have other videos with this kind of limit, so I will also have the links in the description. I will also have the links to those videos in the description if you would like more practice. That's it.